This is another in the series of lectures on the history of the computer that follow a documentary created around 1990 called The Machine That Changed the World. It's an excellent documentary, and I encourage everyone to find it on this website. You'll find it both informational and entertaining. This lecture is on the third in this series. This video was called The Paperback Computer. You may recall that in our last lecture, we concluded the 1950s with this significant development in the evolution of hardware, the integrated circuit, that was co-invented by these two gentlemen, Mr. Robert Noyce and Mr. Jack Kilby. At the end of this lecture, we will be introduced to another significant milestone in the evolution of hardware, the microprocessor, which was also developed under the leadership of Robert Noyce after he co-founded the Intel company. Moving into the 1960s, IBM introduced about 1962 the IBM 360 computer. This replaced one that we studied earlier, their first entry into the commercial computer business, the IBM 650, that was built around 1954. This one replaced it approximately in 1962. This computer also introduced another significant software development of the period, the operating system. In our last lecture, we learned about the development of the early programming languages, Fortran and COBOL, and how they helped the development of software to a great extent, in that it separated what the computer did from the physical hardware. Programming of software was still very complicated because the programmer had to write the instructions to make the computer do everything. Not just the responsibilities of the application that he or she was trying to develop, but things like just the moving of information or moving data around in memory. The programmer had to write the code to do that. Just to put things up on the screen, the programmer had to write the code to get it from the keyboard to the screen or from memory to the screen. The programmer had to write the code to make the printer do its thing or to make any physical devices perform like they should. And so instead of concentrating on the application at hand, a great deal of time was spent just moving data around. Well, the operating system is a level of software that took over that responsibility. It was responsible for managing the resources of the computer, resources like memory, keyboards, other types of devices, monitors, and so on. And this level of software took a great load off the application development because now the programmer could concentrate on writing code to make the computer do the task that they were really trying to make it do. So rather than write the instructions to make the printer, for example, do a line feed, he would just simply put in a line of code to tell the operating system to handle that. So the operating system represents a significant improvement or evolution of computers and software of the 1960s. There were other people that were instrumental in this maturing of this wonderful new technology that we've come to learn to use and become very accustomed to having around. One of these gentlemen was Mr. Ivan Sutherland. Mr. Ivan Sutherland is considered to be the father of computer graphics. He was one of those early pioneers who recognized that this technology could do more than just crunch numbers. Mr. Sutherland, when he was working on his PhD, was involved with the development of the Sketchpad software package. Let's take a look at a brief demonstration of Sketchpad.
Ivan Sutherland's programs can draw straight lines and circles.
Well, that's about what you do in the drafting equipment anyway, isn't it?
That's a very good start.
T-squared.
In order to do this, we can position this bright spot in the middle of the cross that you notice at a desired location. And we press the button to command the computer to draw a line. It will draw a line from this position where I am now to any subsequent position of my light pen. This is much like a rubber band stuck on two pins. One is nailed on the screen here, and the other is at my light pen. So I can position this anywhere I want. Now, I lost tracking there. I moved the pen too fast, and that told the computer to stop drawing the line. Well, if you notice, that bright dot will jump onto the line as I get close to it.
Well, the dot in the center of the cross, when you get close to the line, jumps over onto it.
Correct.
Why does it do that?
It's much like a gravity field. At the end point, it is even a higher gravity field to allow us to position the point exactly on the line, or in this case, exactly at the end point. This allows me to move my pen quite coarsely, be sloppy while I'm drawing, and get a precision drawing out at the same time. So now I'm going to draw a second line, and even a third one. Now, in an ordinary pencil and paper drawing, all we have is this particular picture. But the computer understands the geometry of the drawing here. What do I mean? I mean that if I point at this particular point and tell the computer to move that point by another push-button command, it will move not only that point, but all three lines that are attached to it.
And the delay between it's doing what you want it to is because it's computing all these changes.
That's correct. Now, if I made a mistake, I could delete my mistake by pointing at the line in question, for instance, and pressing the appropriate button. It's gone. Now, I mentioned before we could draw circles also.
Right.
In order to do this, I must first indicate the center of my circle. Let's choose it to be here.
That was a demonstration of Sketchpad, a product that Ivan Sutherland created when he was working on his PhD. It is amazing, isn't it, how far the technology has come since then. That seems so primitive to us in light of the kind of tools that we have today with our computers. But at the time, that was state of the art, and it took a very creative, imaginative man to come up with a product like that. Now we're going to listen to Mr. Ivan Sutherland himself at a presentation that he made a few years ago. I'm going to let this one run through its entirety so that we can all listen to his thoughts on the topic at that time.
Of course, Xerox PARC did a great deal of man-machine interaction work. I think Steve Jobs came around to visit PARC and saw what was going on with the Alto, and the Macintosh was the result of that. So I was, a party to much of this development that went on, either as an observer or a participant. And I think it's been an exciting period. Sketchpad is now nearly 50 years ago, and it's been 50 years of a continuous development of usability of machines for all kinds of purposes. And of course, the machines are thousands of times more powerful now than they were when we started. The important question for the future is, where do we go from here? I was amused to see that the religious wars about how to interact with a computer broke out right in this room this morning. And I've watched those religious wars over and over and over again. And my counsel is, live and let live. The right editor to use is the one you know. Okay, the right kind of bicycle to ride is the one you know. Okay, the right language to use when you speak is the one you know. And the same is true with computer interfaces. The one that you should use is the one you know. And I have no objection to a command line person who says, I like command line. They're terrific, and if you understand them and you use them, a few keystrokes get you a lot. And the people who love command lines just say they're the only thing to use. all of the measurements that I know of productivity using computers say that people who have good ideas about what to do are lots better at doing them independent of the tools. I will assert that Picasso would have made terrific art on computers if he'd had them. Okay, what was great about the man was not the tool he used, but what was in his head, how he was able to do it. And I think the same is true in sort of every field of human endeavor. I don't know how many of you saw Monsters, Inc. Can I see a show of hands for Monsters, Inc.? I loved that movie. It was a terrific movie. Now, what was great about that movie? Was the computer great about that movie? No. It was Lasseter's direction. It was the story. It was the fact that you could immerse yourself in a world that was quite unlike your own, in which infants were terribly frightening. And then there's that wonderful scene of all the doors. I mean, what a wonderful thing. What an image it creates. And it would have been hard to create those images by drawing them in the old Disney style, but not impossible. And what's wonderful about that work and what's wonderful about what Pixar is doing is not the technology, it's the results. And I kind of feel that we celebrate the people who get great results out of whatever technology. We celebrate the great artists who got wonderful things with oil on canvas. We celebrate the great sculptors who were able to find inside that hunk of marble some beautiful shape. All they did was to remove the parts that weren't David, right? And it didn't matter what tools they used to do it. It didn't matter how they polished the marble. We don't care at the end. But what we admire is the ability to visualize that shape. And thank heavens that people are all different, that some of us see things differently than others. And, I find beauty in computer programs. You can look at a computer program and go, wow, this is wonderfully pretty. And some computer programs are prescriptive. They tell the computer what to do. And other kinds of computer programs, called the functional programs, tell the computer what is desired and let the computer figure out how to get there. And the forefront of computer science today is trying to figure out different ways to get good results without having to describe step by step what they should be. And how are we going to continue to get another 1,000-fold increase in computing power over the next 10 or 15 years? A critical problem to the continuing flow of capability that we've become accustomed to over the last 30 years. We've now run out of improved speed on individual computers. We have to figure out how to use banks of them together. Nobody knows how to do that. It's going to require a whole new set of thought. What I find exciting about the opportunities that there are around this field is there's lots of things still to be done. And I think the excitement that I sense in this meeting comes from the realization that there is that potential. And I urge you as you go forward to do the things that you find exciting. It doesn't matter what you do. What's important is that you find it exciting, because the things you find exciting will lead you both to your own pleasure but also to the pleasure of others, because you're likely to do them well. And we admire things that are done well, whatever they are. A fine meal well cooked, a fine poem well crafted, a fine letter. It's hard to write a short, fine letter, right? But when you get one, it's really nice. A fine conference, and this has been a terrific one. Some organizers put together a program here that's been interesting and varied, and I think they did it because they love the subject. I'm glad I came to meet all of you and participate here a bit. And I think I like to look forward and say, what's the future going to be? My father was fond of talking about the birds of Uchi-Kuchi. He said, don't be a bird of Uchi-Kuchi. Why not? Well, they always fly backwards so they can see where they've been rather than where they're going. And what I find interesting is, where are we going?
That was Mr. Ivan Sutherland himself, and a very, very interesting and creative individual. It's obvious from listening to him speak. The real pioneer in the evolution of computer technology. We will hear more about Mr. Sutherland in another lecture on the development of the internet. In fact, Mr. Sutherland was at one point the second director of the department that was responsible for developing the very first global computer network. It was called ARPANET. It initially had 4 nodes and went operational in 1969. Mr. Sutherland was also influential with the development of the internet. So a real pioneer, and it's really interesting as we watch to see how impressed someone of this intellect is with Monsters, Inc. That was just wonderful. Now we'll move on to another pioneer in those early days of the 1960s in the development of the user interface that we're familiar with today, and that is Dr. Doug Engelbart. Dr. Engelbart was the creator of the original computer mouse. Dr. Engelbart, also a very influential pioneer in the evolution of computer. We heard Ivan Sutherland mention Xerox PARC. We all may think of Xerox as the copier company, but Xerox was a pretty significant influence in the early days of the evolution of the computer. They set up a research facility in Palo Alto, California. As a matter of fact, that's what the PARC stands for, Palo Alto Research Center. They put together a team of scientists of the caliber of the Dr. Sutherland's and Dr. Engelbart's to do research into human-computer interaction at Xerox PARC. Xerox PARC is the nurturing home of the graphical user interface. You heard Dr. Sutherland mention that Steve Jobs of Apple went to Xerox PARC on a tour and saw what they were doing, interacting with the graphical user interface, and went back to Apple, and he is quoted as having said this himself, that we have to start all over. The world has changed. I have just seen a better solution. That's when they started working on their early computers with the graphical user interface. And in spite of what you may have heard, Macintosh was not the first one. The first one that Apple put out was one called the Lisa, a predecessor to the Macintosh. And I had thought for years that that was actually the first commercial computer with a graphical user interface, the Apple Lisa. But it was pointed out to me in an earlier session that Xerox, in fact, introduced one called the Xerox Star, and that was the first computer with the graphical user interface. But the Palo Alto Research Center for Xerox was the home of a lot of the modern technology that we enjoy today. And now we're going to finish off this part of this lecture as we segue into the 1970s with the next great invention in the evolution of hardware, and that is the microprocessor. Prior to the microprocessor, there were a number of physical components of a computer system that included such things as a device called a control unit, which was responsible for decoding instructions for the computer to perform. And there was another device called an arithmetic logic unit that's purpose was to do mathematical operations and also logical decision making, greater than, less than, true, false, and so forth. And then there were some very high-speed storage units called registers that existed. And then there was another device that held memory. That memory was referred to as RAM. Well, the microprocessor combined the control unit, the arithmetic logic unit, and the registers along with other circuitry on a single silicon chip, which just took an entire room and shrunk it down to just a few inches. The only thing it didn't include was the RAM. RAM is still a separate area of the computer, But the microprocessor consolidated a lot of these very complex systems and segued us into the next stage of computer development, that being the microcomputer that was invented in the mid-1970s. The first microprocessor was invented by Intel under the leadership of Robert Noyce, the gentleman we met earlier, in a period of around 1971 in that area. Here's a picture of one of the first microprocessors, the Intel 4004. And it combined all those devices that I just described to you. Here is a later version called the Intel 8080. And the earliest microcomputers used this microprocessor after the microprocessor was invented by Intel. A magazine called Popular Mechanics Magazine put out a notice that they wanted to do a cover story on this new microprocessor, and that they would do it on any computer that someone could actually build using this new microprocessor, because at that time there wasn't one. And a fellow named Ed Roberts took that challenge and built the very first one that you see right here, this little kit called the Altair 8800, and actually built a working machine that would use a microprocessor. Didn't do much. It flashed a few lights according to some instructions that the operator put in, but it was still a computer and it still used a microprocessor. In fact, Mr. Roberts started his own business, MITS, selling kits like this. In fact, Mr. Roberts hired a young man who had just started a company designing basic interpreters for computers, a company called Microsoft. Ed Roberts hired Bill Gates. And that was the very first computer ever built, and it used one of those Intel microprocessors. And we will end this lecture by introducing these two machines. The Apple II, first offered in the mid-1970s. Company started by two young men, Steve Jobs and Stephen Wozniak. They originally sold their little kits and circuit boards at a user group meeting called the Homebrew Club, and that's how they got started. And companies like Radio Shack and Apple just set the world on fire in the the late 1970s. And then in 1980, IBM introduced the IBM PC. So we will end this lecture with that introduction of the microprocessor by Intel and the two microcomputers that really started it all for that age, the Apple II and the Radio Shack TRS-80, and then the IBM PC.